Hello everyone, I am PRANAV VERMA from MTech 8th and today I am going to give a presentation on topic list in PROLOG, which is made under the guidance of Sunny Rakwar sir as a part of my third internal assignment. So the topics that we are going to cover in today's session are introduction about list in PROLOG, representation of lists. We are going to have a deep dive in basic operation on list. Then we will be seeing the introduction of repositioning operations and miscellaneous operations in list. So let us first see what is list in PROLOG. It is a data structure that can be used in different cases for non-numeric programming. Lists are used to store the atoms as a collection. In the subsequent sections, we will be discussing the following topics: representation of list in PROLOG, basic operations on PROLOG such as insert, delete, update, append, repositioning operators such as permutation, combination, etc., set operations like set union, set intersection, etc. So moving towards our first topic, which is representation of lists. The list is a simple data structure that is widely used in non-numeric programming. The list of element will be enclosed with square brackets. A list can either be empty or non-empty. In the first case, the list is simply written as a PROLOG atom, which is two square brackets. In the second case, the list consists of two things as given below. The first item called the head of the list and the remaining part of the list called the tail. So now let us consider we have a list L which has A, B, and C elements. If we write tail, which is BC, then we can also write the list L as L equal to A vertical bar, which is also known as pipe tail. Here the vertical bar pipe separates the head and tail parts. So the following list representations are also valid. For these properties, we can define the list as a data structure that is either empty or consists of two parts, a head and a tail. The tail itself has to be a list. So moving towards our next topic, which is basic operations on list, in which we are going to see several operations such as membership checking, which stands for the operation in which we check that a member that is specified is present in the list or not. Length calculation returns the length of the list. Concatenation is used to concate the two lists. Delete item is used to delete an item from the list. Append item is used to append items into a list. Insert item is used to insert an item in a list. So moving towards our first operation, which is membership operation. During this operation, we can check whether a member X is present in the list L or not. Well, we have to define one predicate to do so. Suppose the predicate name is list member XL. The goal of this predicate is to check whether X is present in L or not. To design this predicate, we can follow these observations. X is a member of L if either X is head of L or X is member of the tail of L. Length calculation. This is used to find the length of list L. We will define one predicate to do this task. Suppose the predicate name is list length L, n. This takes L and n as input arguments. This will count the element in a list L and instantiate n to their numbers. As was the case with the previous relations involving list, it is useful to consider two cases. If the list is empty, then the length is 0. If the list is not empty, then L equal to head by tail, then its length is 1 plus length of tail. So on the right side, there is the output of PROLOG engine performing the length calculation predicate. As you can see that there are many examples. And the first example, a list is provided containing 10 elements, so its length is 10. In the second example, a list is provided who does not contain any elements, so its length is 0. And in third example, there are three lists provided. There are three lists are provided in a list, so the length is 3. So moving towards our next topic, which is concatenation. Concatenation of two lists means adding the list items of the second list after the first one. So if the two lists are ABC and 1, 2, then the final list will be ABC 1, 2. So to do this task, we will create one predicate called list concat that will take the first list L1, second list L2, and the L3 as the resultant list. There are two observations here. The first list is empty and the second list L. Then the resultant list will be L. If the first list is not empty, then write the this as head pipe tail concatenate tail with L2 recursively and store into new list in the form head new list. So on the right side, as you can see, the Prolog engine's output for list concatenate predicate. As you can see that there are three arguments. The first argument is the list one, the second argument is list two, and the third argument is the resultant uh, variable which stores the list, resultant list. So moving forward towards delete from list, suppose we have a list L and element X, we have to delete X from L. So there are three cases. The X is the only element present, then after deleting it, it will return an empty list. If X is the head of L, the resultant list will be the tail part. If X is the tail part, then delete from there recursively. On the right side, there is the output of the Prolog engine. So as you can see in the first example that if you want to delete an element A from the list A, E, I, or U and store its output to the new list, then the new list contains E, I, O, U, which is the list resultant list after deleting the element A, and more examples are given below that. Moving towards the next topic, which is append into list. Appending to list means adding two lists altogether or adding one list as an item. Now, if the item is present in the list, then the append function will not work. So, we will create one predicate, namely list append L1, L2, L3. The following are some observations. Let A is an element L1 is a list, the output will be L1 also when L1 has A already. Otherwise, new list will be L2 equal to A pipe L1. So on the right side, as you can see the output of the Prolog engine, the list append predicate has three arguments A, E, I, O, U, which is a list, and a new list which will store the resultant operation. So the new list now contains the uh, concatenated list which is AEIOU, or concatenated or appended list which is AEIOU. And following are some more examples in which you can see that an element which is already present in the list is, when we try to enter the same element, the list remains the same. And if we try to enter a list in a list, then the list gets entered as whole, not like a single element from the list gets entered in the resultant list. As in the example, we can see that AB is a list, so the whole list gets inserted in the resultant list. So moving towards our next topic, which is repositioning operations of list items. So first operation, which is permutation. This operation will change the list item position and generate all possible outcomes. Reverse items. This operation arranges the items of the list in reverse order. Shift items. This operation will shift one item of the list to the left rotation. So it will perform left rotation. And order items. This operation verifies whether the given list is in order or not. So moving towards our last topic, which is miscellaneous operations on list, in which we are going to see even and odd length finding, verifies whether the list has odd number or even number of elements, divide a list into two lists, and these lists are of approximately the same length. Max retrieves the element that has maximum value from the given list. Sum returns the sum of the element of the given list. Merge sort arranges the element of the given list in order using merge sort algorithm. So we are just going to see the introduction about this topic. So these is the references that I have used in making of this presentation, and that was all from my side. This is Pranav Verma signing off from the topic list in Prolog. Thank you.